Welcome to VHDL tutorial. In this video, we will focus on modeling Moore FSM. Moore FSM. FSM stands for finite state machine. Then what do you mean by a finite state machine? A finite state machine or FSM is a model computation based on a hypothetical machine made of one or more states. So a finite state machine contains one or more states only active at the same time. So the machine must have transition from one state to another state in order to perform different actions. For example, a traffic light. A traffic light changes its sequence from one state to another. So we have an example for FSM. The is traffic light. Okay, then we will Moore FSM. So the output of a Moore FSM depends only on the state and not on its inputs. So please note, the output of a Moore FSM depends only on the state and not on its inputs. Diagram of a Moore machine. We have different states ST0, ST1, ST2, ST3, etc. ST0 means state 0 and ST2 means state 2. ST1 represents state 1, ST3 represents state. Then in this figure we have Z. Z means output. The value of Z may be 1 or 0. That means output may be 1 or 0. Then A represents input. The value of A will be 0 or 1. A is equal to 0 or A is equal to 1. So let us focus on this state diagram. So start with the ST0. ST0. We have ST0 is here. At ST0, that means in state 0, the value of Z is equal to 1. Then in ST0, if A is equal to 0, the machine will stay on state 0. If the value of A is equal to 1, that means if the value of A is equal to 1 means if the input is 1, the machine will switch from state 0 to state 2. In this state diagram, if the value of A is equal to 1, the machine will change its state from ST0 to ST2. So in ST2, the value of Z is equal to 0. That means we have the definition. The output of a Moore finite state machine depends only on the state and not on its inputs. Here the output is Z. The output Z depends on the state ST2. That means Z is equal to 0 in the case of ST2. So in ST2, if the value of A is equal to 0, then the machine will switch from state 2 to state 1. Then if the value of A is equal to 1, then machine will changes from ST2 to ST3. Then at ST1, the output Z is equal to 0. Then also at ST1, if the value of A is equal to 0, the machine will stay on state 1. Then if A is equal to 1, the machine will change from ST1 to ST3. At ST3, the value of Z is equal to 1. The value of Z will be 1. Then also at ST3, if A is equal to 0, the machine will stay on state 3. It will not change its sequence to another state. Let us assume if A is equal to 1, what will happen? The machine will changes from ST3 to ST0. Here you can see if A is equal to 1, the machine will change from ST3 to ST0. So this is the state diagram of a Moore machine. Then we have to go to the program. Here the entity, you can avoid this library statement. the first statement. You can avoid this first statement and you can use our common header files like library IEEE and IEEE std logic 1164 dot all. Then the entity start here. So we can start with the entity more FSM is, the name of the entity is more FSM. The declaration of ports, port A, comma clock, input bit type. So A and clock are input ports of bit type. Then Z out MVL. You can replace this MVL type with bit type. So Z out of bit type. Here Z is output. Then A is input and here a clock signal is present. Then end more FSM. Then architecture. Then architecture FSM example of more FSM is. So begin with the architecture. FSM example of more FSM is state type is ST0, ST1, ST2 and ST3. Here state type is an enumerated data type. You can refer the enumerated data type in the data type section. Then the value of state type is ST0. ST0 means state 0. Then ST1, state 1, state 2, state 3. Then signal more state. More state is a signal of which type? It is a type of state type. So the signal more state represents the state type data type. Then begin process statement. The sensitivity list is clock. So all the statements inside this process statement will execute only if there is a change in clock signal. Then begin if clock is equal to 0 and clock event. Then so this statement represents the lagging edge of clock. So if clock is equal to 0 and clock event, then case more state is. So during the lagging edge of the clock, the program will start with the case statement. You need to refer the syntax of case statement in the chapter behavioral modeling. Then case more state is when ST0 is Z is equal to 1. So more state, we will check the value of more state. If the value of more state is state 0, we have the value of more state. More state is a state type. So more state can receive values like ST0, ST1, ST2 and ST3. So if the value of more state is ST0, then Z will be 1. We have the state diagram here. So please note, in the case of ST0, the value of Z is equal to 1. So from the program when ST0 Z is equal to 1, then if A is equal to 1, from state diagram, if A is equal to 1, more state will be ST2. Then in state diagram, when A is equal to 1, more state will be ST2. Okay, so more state will be changes from ST0 to ST2. Then end if. Then next case, when ST1, if the state is ST1, then what will be the value of Z? Z is equal to 0. Okay, from state diagram, refer ST1. Here this is ST1. In the state ST1, the value of Z is equal to 0. Then if A is equal to 1, then more state will be ST3. Then in the case of ST1, this is ST1, if A is equal to 1, the machine will transit from ST1 to ST3. Then end if. Then next case is when st2, then st2, when st2 is equal to 0. Okay, then we will go to st2. This is st2. So in state st2, value of z is equal to 0. Then if a is equal to 0, from the program, if a is equal to 0, then more state is st1. Okay, then let us check st2. If a is equal to 1, here in st2, if a is equal to 1, the machine will changes from st2 to st3. More state is st3. Then when st2 is equal to 0, if a is equal to 0, then more state is st1. If a is equal to 0, the more state is st1. Else more state is equal to st3. That means if a is equal to not 0, the state will transit from st2 to st3. Then end if, then the final condition when st3 is equal to 1. Let us check st3. So this is st3, and at st3 the value of z is 1. Then if a is equal to 1, then more state is equal to st0. If a is equal to 1, the state will be st0. That means the state will changes from st3 to st0. Then end of the case statement. Then end if, end process, end FSM examples. Okay, so this is more FSM. You need to code the program according to the state diagram of this more machine. Okay, thank you.